I greet you in Jesus' name. I hope you are doing well at home and also at the church. I want to welcome those of you who are watching me from home, and I want to tell you that God is good. God will encourage you at this time when you people are not going to school. I've decided to teach you something today so as to remind you of the things that we've been doing at school to help you with your revision. We will be having a series of these things, maybe 5 of them, such that you can not forget the things that you'll be learning at school. I've decided to take a topic in mathematics called trigonometry, and that's what we are going to learn. So we will start by the simple things that you learned when you were in primary school, and then we will be progressing. But whatever we want to talk about today, mostly will benefit you as a Form 2. If you are a Form 3 and also Form 4, note that you can use it as your revision. A time is coming, one of these series, maybe the third one, we'll be able to discuss things that are very relevant to those people who are in Form 3. Welcome. I'm called Ominde, Samuel. Many of you know me as teacher at the church, but today I'm your class teacher. May God bless you so much. I said that we will be learning about trigonometry, but you see, there's no way we can learn about trigonometry before I talk about a figure of this type. Someone can tell me the name of that figure. This is a three-sided figure. The three-sided figure in mathematics is called a triangle. That is good, it's called a triangle. So I have a triangle. Even this one is a triangle. Anything that is three-sided is called a triangle. So I have some triangles on the whiteboard. We normally note that triangles are normally named. Like for example, we normally name them by the vertices. Like for example, okay, at the vertices, the rule is that when you are naming a triangle, you use capital letters. So like for example, I can say that I have triangle ABC. Those are capital letters. X, Y, Z, etc. So these are triangles. My friends, something that you need to notice that if you have a triangle, we are also interested in knowing the lengths of the sides. So even these lengths of the sides are always named. But with them, conventionally, we name them using small letters. But I want to be very careful as far as the way we are going to name them, such that you will not be confusing things in future. You are able to see that I have triangle ABC. If you have this triangle, looking at A, the side which is opposite A, in this case, side BC, this side, when we are naming it, we are using letter small a. So, in that case, we'll be having small a. Small a is a length, maybe 10 centimeters or maybe 15 centimeters, etc. When you look at this side, it is opposite to angle B. Therefore, it's named small b, and therefore, this one is small c. Those ones are lengths, and therefore, they are in various units, maybe centimeters, millimeters, kilometers, etc. I want somebody to try. My students at the class here, can someone name for me this length in terms of the letters that I have, X, Y, Z? What do you think will be this? Yes, Protas? You see, when you look at this triangle X, Y, Z, this is vertex X, this side Y, Z is opposite to X, and therefore this side is called small x. True? Yes. Who can try to name for me this one? Small y. This one is small y. Thank you so much. And who can try this one? Small z. Small z. That is good. I just want us to try to name this one also, such that I will know that you people were attentive. Q, capital. R, capital. Z, capital. Someone to name this.
Small q.
Small q, thank you. What about this?
Small r.
Small, not this R, by the way, not this R. Not this R, but it is a small r. And then this one is small z, and this one is small q. Is that okay?
Yes.
That is fine. Thank you so much for knowing how to name the sides. Today, okay, these things that we are discussing, we are discussing triangles in general. But I want us to do some revision about triangles, a certain type of triangle that all of you did when you were in primary school. Yes. If you have a triangle, like the one I'm drawing right now, you see, these ones are angles, the angles. A triangle whose one of the angle is 90 degrees is what you want to talk about. 90 degrees is always indicated like that. So we can say that triangle KTB is a right angled triangle because angle KTB is 90 degrees. Is that okay? Is that okay?
Yes.
Now, many are the things that you learned about a right angled triangle. We want to concentrate on the right angled triangle, at least for today's lesson. We will be singing things, and these things that we will be singing will be based on a right angled triangle. What do I mean by a right angled triangle? A triangle whereby one of the angles is 90 degrees. It is important for you to note that the angle sum of a triangle is 180 degrees. And therefore, for a right angle triangle, we are told that one of them must be 90 degrees. Good. If you have a right angle triangle, we have two shorter sides and one side which is longest. It is longer than the other two. The side which is longest is called hypotenuse. Side KB is hypotenuse. Side KT and side TB are shorter sides. That one is something that we have to note. You knew it when you were in primary school. You know, in mathematics, we are always interested in knowing certain things as far as a triangle is concerned, any triangle. But today we are talking about right angle triangle. It is important for us to know about the length of KT. What is the size of the length? What is the size of this? What is the size of this length? Now, when we were in primary school, someone told us that there was a scientist whose name was called Pythagoras. Pythagoras developed a relationship between these sides. He is a mathematician who developed the relationship between these three sides. Imagine this is what Pythagoras did, and then he realized. Pythagoras was a mzungu, and this is what he did. He had a right angle triangle. Then he realized that if this side is 4 units, if it is divided into 4 equal parts, and this one side is divided into 3 equal parts, then the length of hypotenuse is as if they are 5 parts. It's as if they are 5 parts. This is what he developed. This is what he realized. Pythagoras, you see, he was a scientist. So he was playing with the triangles. Then he realized that there is a way these things are related. Now, what he did again is that he tried to form small squares from all the sides. For example, these ones are 4 So he made a square here. He made another square here. Pythagoras theorem is playing. He made a square here. Then he realized that if this square is drawn, it's divided into 4 equal parts. This one also done like this. 4 of them. He awake like that. Alafu this one, 1, 2, 3, 4. 1, 2. Are they 4? No. Assume that these lengths are equal. Then Pythagoras theorem learned that the number of squares on this side, together with the number of squares on this side, if they are counted, they are equal to the number of squares on this side. That is what Pythagoras theorem realized. How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. And therefore these ones are 16. These ones are 9. Na hizi ni ngapi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. These ones are 25. So Pythagoras realized that, kumbe, what is happening is that this side, whose length is 4 units, and then this side, whose length is 3 units. Suppose he squares 4, and then he squares 3. Then he gets 3 squared is 9, 4 squared is 16. If they are added, you get 25, which is the sum of the smaller squares on the hypotenuse, which made him to develop a theorem called Pythagoras theorem, which says what? Pythagoras theorem says that in any right angle triangle, the sum of squares of the 2 shorter sides is equal to the square of the hypotenuse. This. The squares on this side plus the squares on this side is equal to the squares on the hypotenuse. That is a theorem which these days we don't want to call it a theorem because it's working. You see, it's not a theory. It is true that if you have any right angle triangle, it can be any number. Maybe x kilometers, y kilometers, r kilometers. This is 90 degrees. It is true that square of r, if you square r and then you add y, which has been squared, the answer is equal to x squared. Pythagoras theorem. Hello, is that okay? Yes. Is that okay? Yes. Yes, if that is okay, then I want to check whether you people are understanding what we are talking about. Millicent, look at the board. Kindly look at the board. If you are looking at the bed, can you tell me the relationship between ABC in this one? Can you tell me?
Yeah.
Ebu sema.
A square plus B square is equal to C square.
Wrong. This is not a right angle triangle. This is not a right angle triangle. What I mean is that Pythagoras theorem is only working if it is a right angle triangle. This is not a right angle triangle. This is not 90 degrees. So, my friends, not always that. For this formula to work, for Pythagoras theorem to work, it has to be a right angled triangle. Thank you for that. So it means that, what that one means is that, mathematically, you will be given a triangle. You will be given, maybe this one is 12 units, and maybe this one 20 units. Someone will ask you to get this. Simple. Just use Pythagoras theorem. Square 20, alafu square 12, add those things. The answer will be the square of this. So in this case, we will square root the sum of square of this and this, then we get the answer. Is that okay? Sawa. Thank you. May God bless you. But this one we were doing was as far as primary school mathematics is concerned. So let us move to secondary level. You know, if you are given this problem, for example, this is 12 units, alafu this one is 20 degrees. Someone can ask you to get this length. Someone can ask you to get this length. This one will be very hard because I can't use Pythagoras theorem. How can I use Pythagoras theorem? It can't be used because I don't know this one. I also don't know this one. I only know 12. Ngumu, sindio? This one I can't do. It is hard. Pythagoras theorem cannot work. But you see, if I am given maybe, okay, if this is 20 degrees, this is 90, what do you think is the size of this angle? Can't you get the size of this angle? You add the two, 90 plus 20 is 110. Yes. 110 minus 180 minus 110 is 70. So that one is 70 degrees. That one I can do. I can get this angle if I'm given this because this one is already there. But it will be hard for me if these people can give me, say this is 30 degrees. This one has not been given. This is 60 degrees. And then someone is asking me to get that length. Ngumu. This is hard. You can't get. But thanks to mathematicians developed something that today we want to just lay the ground of what can be done, such that in life, if you come across a triangle whereby, a right angle triangle whereby one angle is given, one side is given, somebody is asking you to get the other sides. We want to learn what you can do in such a case. Also, we want to learn what you can do. For example, in this one, you have been given all the angles, and maybe one side, it could be even this one, maybe 10 centimeters. Someone can want to ask you to get this size. You see, this one you cannot use Pythagoras theorem. I'm a teacher. Oh, my friend, do you think you can use Pythagoras theorem to get this length? How? What are you going to square with the words? Don't you see we have two words? Because there are two words, we cannot get. Hello? Yes. So, there is something that we want to learn. I want you people to be attentive so as to know what I want us to learn. After we have known something here, it is going to be possible for us to tackle any question that we'll be coming across. Friends, what I want us to learn is called trigonometric ratios. Trigonometric ratios. You see, we are no longer in primary school. We are in advanced level. So, tuachane na vitu vya primary. I want us to learn about how to name sides of a right angle triangle. After we have known how to name sides of a right angle triangle, what I want to talk about will be very easy. My friends, look at this triangle. Is it a right angle triangle? Is it a right angle triangle? No. Yes. This is a right angle triangle. Now, when you have a right angle triangle, there is always an angle you can refer to. Suppose you are referring to this angle. Let me call it angle theta. That is the size of that angle. Then, these sides should be named. The name of side which is opposite to the angle is called opposite. The name of the other shorter side is called adjacent. This one will remain to be hypotenuse, vile was inaitwa. Is that okay? Yes. This one is called opposite, this one is called adjacent, this one is called what? Hypotenuse. Really? Yes. We have three names. Yeah. One is called adjacent, another is called opposite, another is called what? Hypotenuse. Looking at my diagram, you know, if the angle we are talking about is not this, but suppose the angle is now this one, maybe angle k degrees, then at this time, this is now the opposite. This is now the adjacent, and this is what? Hypotenuse. Is that okay? Will that one confuse us? No. It should not confuse us. It is important for you to notice that should you come across any triangle, know the type. Know the type. If it is a right angle triangle, looking at a certain angle, that one should be able to help you to know where is the adjacent, where is hypotenuse, where is opposite. Is that okay?
Yes.
Back to the trigonometric ratios. We have 3 of them that we want to learn today. There are several of them that will be learned at advanced level. Today, I want us to learn one of them, which is called sine. Another one is called cosine. And there's another one called tangent. Sine is sine of an angle. Cosine of an angle, and also tangent of an angle. Kindly note that. What is sine of an angle? What is tangent of an angle? And also what is cosine of an angle? Remember, we are dealing with a right angle triangle. So, I want to have a triangle here, which is a right angle triangle. And then we are going to deal with this angle. So please, the way we were learning, what do you think will be the name of this side? Is this hypotenuse?
No.
Is this hypotenuse? No. Is this adjacent? No. What is this? Opposite. This is opposite. Is that okay? Yes. So let us call it opposite. What about this? Adjacent. This is adjacent. And then this is hypotenuse. Is that okay? Is that okay? Yes. I want us to learn this. The sine of an angle and the cosine of an angle or tangent of an angle, these are ratios. These are ratios which are comparing the sides that you want to deal with. For example, a ratio of opposite divided by hypotenuse. There is also another one. Adjacent divided by hypotenuse. Hypotenuse. Lastly, there is what? Opposite over adjacent. Hello? Hello? Yes. There is a ratio which is called opposite over adjacent. We want to just play around with these things. Another ratio which is called adjacent over hypotenuse. Another one is called opposite all over adjacent. So, is it very hard? I think it is hard. This one is very hard. But there's a way that we can do such that we remember this thing. Yeah. This is what we can do such that this thing that seems to be very hard will be made easy. Someone to read this. Can you read this for me? So, is that okay? Yeah. Alafu this one is ka. Alafu this one is toa. Sokatoa. Can you say it again? Sokatoa. Say it again. Sokatoa. 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 It means that sine of an angle is equal to opposite all over hypotenuse. Cosine of an angle is equal to adjacent all over hypotenuse. And then tangent of an angle is equal to opposite all over adjacent. So if you are planning to forget, please just sing Sokatoa. Sokatoa, 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 Sokatoa. Is that okay? Yes. What is sine of an angle? Opposite. Sine of an angle? Opposite over hypotenuse. Cosine of an angle? Adjacent over hypotenuse. Tangent of an angle? Opposite over adjacent. So, it means that, my friends, it means that if the triangle that we are dealing with, suppose this one is angle 20, and this one is 3 units, this one is 4 units, this one is 5 units. No, that one cannot be angle 20. It is angle theta. Then, it means that cos theta, cosine of theta, cosine of the angle theta is equal to, what is cosine is what? Opposite all over hypotenuse. Where is opposite here? Where is opposite here? Is it 5? Is opposite is 3? Opposite over hypotenuse. Where is hypotenuse there? 5. Alafu unapewa tick. Hiyo ni tick. Si ndio? Suppose you want to get, I want somebody to get for me tangent of this angle. Tangent of this angle that I've drawn. Tangent of that angle. Who can try? Tangent of the angle. What over what? As far as this thing is concerned. 3 over 4. It is good to say that tangent, toa, opposite. Where is opposite? 3. Adjacent 4. Umepata bwana. Tick. What is remaining? Sine. Sine of the angle will be equal to what? Hapana, unasema sine. Sine, so. Opposite all over hypotenuse. Ndio? Where is the opposite here? Opposite is 3. Hypotenuse is 5. Good. So, that is the thing. That is the thing. I said that we wanted to learn something that you can do, such that if you are given any right angle triangle, someone is asking you to get the sides or the angle, you are able to do that. So for today, we will end there. But the next series, the next lesson will be whereby now we'll be doing these things actually. What we mean is that, let me tell you a miracle, bana. Mathematicians are not sleeping. People who are doing mathematics are not sleeping. They are not sleeping. This is what they were doing sometimes. Unajua mahesabu ni kucheza na figures. They took an angle like this. They drew a triangle whereby this angle is very small. It means this one was very short. And then they increased this length like that. It means it started from 0, 1, 2, 3, mpaka inakuwa hivi. So they were playing around with those things. And then as they were playing around with them, they were measuring this and also this. For various angles. Each time wana calculate wanaandika. Walifanya kazi ngumu sana. Hiyo kazi walifanya, and as they were dividing, they printed their finding in a table such that siku hizi kuna, if you want to get sine of 30, if this angle is 30, it has been worked out for you. It is in the mathematical table. Equal. So this is what we will be learning in depth in our next lesson, whereby we will be now doing the actuals. Today it was introduction. But thank you so much, because you will always be remembering SOHCAHTOA. SOHCAHTOA is what? Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. May God bless you. So, you at home, please go and take your textbook, the one that you've been using. Ile mwalimu alikupatia. Open the page for trigonometry. Do some problems there. Should you have any difficulty, please, I'm at the office Deliverance Church. Ukuje tu, tutafanya pamoja. May God bless you. Amen.
The Lord, your healer. This is his word. I am the God that he